Let's get started on today's notes over naming and classifying angles. Let's start with some vocabulary words. What is an angle? An angle is a figure formed by two rays with a common endpoint known as the vertex. And so in this image of this angle right here, I can see two rays, ray DF and ray DE, and they share a common endpoint, which is point D. The interior of this angle is the set of all points between the sides of the angle. This right here is the interior of this angle. The exterior of an angle, let's use a different color here, is the set of all points outside the angle. So all of this, it doesn't really want to do that. Let's see if I can do this. All of this is the exterior of this angle. It's the outside, the set of all points outside the angle. And now how can I name this angle? And I'm not really sure why it did that, but how can I name this angle? I can name it using its vertex. I can call it angle D. I can also name it with 3 points on it, E, D, and F. So I can call it angle E, D, F, right? E, D, F. I can also call it angle F, D, E. So I need 3 points to name this angle. You want to make sure that middle letter is your vertex. And that always has to be your middle letter when you're naming an angle. I can also call it angle 1. Let's look at our next image. It says to write the different ways you can name the angles in this figure. Well, let's look at this first angle right here, angle 1. I can call it angle 1. I can also call it angle BAC, angle BAC. I can also call it angle CAB. I just want to make sure my vertex is that middle point. Let's look at this angle right here, angle 2. I can call it angle CAD, and I can call it angle DAC. Now notice that I can't call either of these angles angle A, okay? Because angle A, if I were to do that, what angle am I talking about? Okay, so when you have two angles that are right next to each other, they share a common ray, then you can't just name it by the vertex. You need 3 points, or you need maybe the number if there's a number there, but you cannot use just the vertex. So let's move on to the first postulate that we're going to talk about today. It's called the protractor postulate. And it says, given line AB and a point P on line AB, all rays that can be drawn from P can be put into a 1-to-1 correspondence with the real numbers from 0 to 180. What does that mean? It means that we can use a protractor to measure angles. So if I'm looking at this right here, I've got line AB on my protractor, this middle point right here, at this point right here, okay? And I can see that that line's on line 0, okay? In this protractor, when I'm going to measure this angle measure, there are numbers on the inside of the protractor and on the outside of the protractor. If I'm starting at 0 over here, I'm going to use the inside numbers. So I'm counting up 50. This angle right here would be 60 degrees, okay? So just be careful. There's 2 sets of numbers on the edge. Make sure you're using the right one. Let's move on to measuring and classifying angles. Hopefully this is a review for you, but I still want to point it out because it's good to review. So an acute angle is an angle that measures between 0 and 90 degrees, and it looks something like that, okay? It's a cute little angle. An obtuse angle is an angle that measures between 90 and 180, right? So it looks something like that. A right angle measures exactly 90 degrees. So it looks like this. It's like the corner of a sheet of paper. And we designate a right angle with a little square down here, okay? If you see an angle that looks like a right angle, it looks exactly like 90 degrees, but it does not have that little box right there, you cannot assume that it's 90 degrees. It could be 89.95 degrees. That is not a right angle, okay? So never assume when in geometry. So my acute angle between 0 and 90, obtuse angle between 90 and 180. And then a straight angle is just formed by two opposite rays. So in opposite rays, they share a vertex and they go out in opposite directions. A straight angle measures exactly 180 degrees. In this next section, you can use the protractor postulate to help you classify angles by their angle measure. The measure of an angle is the absolute value, which is always positive. The absolute value of the difference. When we see the word difference, that means we subtract, of the real numbers that the rays correspond with on a protractor. Okay, what does that mean? In 1 through 3, we're going to use this image on the right. It's these angle measures, and I've got a protractor in front of it. Find the measure of angle CDG. Well, that's right here. C, D, and then G. That's this ray right here. Well, ray DC, that's awesome because it lies at the bottom of this protractor in this image on that bottom line. And when it goes out to the left, and I'm going to start, like, how do I determine if I use those inside angles or inside numbers? Those are these right here. Or the outside numbers, those are these out here. How do I determine which ones I use? Well, if I'm starting with that ray to the left, 0 is my outside number, so I'm going to use the outside numbers. And notice ray DG goes between 120 and 130. It's actually at 125 degrees. So that's what that is. The measure of angle CDG is 125 degrees. Because it's greater than 90 degrees, it's an obtuse angle. Let's move on to the next one. The next one says the measure of angle GDF. GDF. Okay, well, that's actually neither of these rays, ray DG or ray DF, lies on the bottom line. So what I'm going to do, and I'm going to zoom in, is I'm going to either use on this protractor the outside numbers or the inside numbers. And for this, whatever you do, just use the same numbers for both rays, right? So in this case, I'm going to use the inside numbers. So DF, that's between 140 and 150. That's at 145. Ray DG, that's between 60 and 50. It's at 55 degrees. So all that stuff that I read to you at the beginning of this, right? The absolute value of the difference of the real numbers, blah, 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 blah. What I'm going to do is I'm going to subtract those values. So the measure of angle GDF is equal to the absolute value of the difference. So the absolute value of 145 minus 55. 145 minus 55 is 90. And the absolute value of 90 is 90. So the measure of angle GDF equals 90 degrees. And because it's 90 degrees, that makes it a right angle. In our next problem, we're going to find, and I'm going to subtract this, the measure of angle GDE. GDE is right here. Okay, it's this angle right here. Ray DE lies on that bottom line. 0 is an inside number. So this other ray, DG, lies between 50 and 60, right at 55 degrees. So the measure of angle GDE equals 55 degrees. It's less than 90, which makes it an acute angle. Let's look at our next section. Congruent angles. Congruent angles are angles that have the same measure. So here we have angle BAC and angle EDF. And notice these little tick marks right here, or arc marks, not tick marks, sorry. Tick marks are for the congruent segments. Arc marks show congruent angles. So they have the same arc marks, which means that angle CAB, and I could call it BAC, but angle CAB is congruent to angle FDE. And because they're congruent, I can say their angle measures are the same. So watch how I write this. Angle CAB is congruent to angle FDE. Therefore, the measure of angle CAB is equal to the measure of angle FDE. Let's move on to the next section, the angle addition postulate. This next postulate states that if point O, or O, is in the interior of angle LMN, then the measure of angle NMO, so NMO, this angle right here, plus the measure of angle OML, OML would be this angle right here, those two angle measures added together would equal the measure of angle NML, that entire thing, okay? So that's the angle addition postulate. I can add those two angles that are right next to each other, and I'll get the measure of the entire angle. So number 4, this says, now what I will encourage you to do is you're given some information and you're given a figure. Awesome that you're given a figure. You don't have to draw it. If you're given information and don't have a figure, draw one. So the measure of angle QRT is 46 degrees. QRT, that's 46 degrees. The measure of angle QRS, that's the entire thing, is 71 degrees. This whole thing is 71 degrees. It says find the measure of angle TRS. We're looking for this angle measure right here. Now, our angle addition postulate, and I'm going to change colors again, says that the measure of angle QRT plus the measure of angle TRS should equal the measure of angle QRS, right? That whole thing. So that's what our angle addition postulate states. What I'm going to do now is, given these numbers, I'm going to plug them in my equation. Well, the measure of angle QRT, we know that. That's 46 degrees. The measure of angle TRS, well, we don't know that, right? That's our unknown. So I'm just going to write the measure of angle TRS equals the measure of angle QRS. Well, we know that to be 71 degrees. Well, now I'm just going to solve this because it's just an algebraic equation that I've set up by subtracting 46 from both sides. And I get that the measure of angle TRS equals 25 degrees. Let's move on. Our next vocabulary term is angle bisector. An angle bisector is a ray that divides an angle into two congruent angles. So you can see ray HI bisects angle GHJ. Thus, angle GHI is congruent to angle IHJ. They're congruent angles. It bisects, that splits it in half. Now, this is similar to a segment bisector. You've seen that before. What's a segment bisector? It is a segment that cuts. It is something that cuts our segment in half, right? And it creates two congruent segments. That's what a segment bisector is. Let's go down to number 5. This says ray UW bisects angle TUV. Okay, well, we know that these two angle measures are congruent because of that, right? That's what we know, given that little bit of information right there. The measure of angle TUW is 5x minus 4. I'm going to go ahead and label that. And the measure of angle WUV is 7x minus 16. Find the measure of angle TUV, that whole angle measure. Okay, well, the first thing I need to do is find the value of x. So I need to set up some equation that allows me to find the value of x. Well, I know that if these two angles are congruent, then their angle measures must be the same, which means I can set these expressions equal to each other. 5x minus 4 equals 7x minus 16. And now I'm just going to solve for x. I'm going to subtract 7x from both sides. So I get negative 2x minus 4 equals negative 16. I'm going to add 4 to both sides. Negative 2x equals negative 12. Now I'm going to divide both sides by negative 2 to get x equals 6. Okay, now I have found the value of x. What can I do now? Plug it in, plug it in. I know, let's just say, the measure of angle TUW, the measure of angle TUW is 5x minus 4. I know that x is 6, so I'm going to plug it in. 5 times 6 minus 4. 5 times 6 is 30. 30 minus 4 is 26. The measure of angle TUW is 26 degrees. Okay, am I done? I'm not. The problem says to find the measure of angle TUV. Well, I know that if this is 26 degrees, this is also 26 degrees because those angle measures are equal to each other. So the measure of angle TUV is going to be 2 times 26, or 26 plus 26. The measure of angle TUV is going to be 52 degrees, and that's my answer. Let's get started on the guided practice portion of the notes. Numbers 6 through 8, I encourage you to find the measure of each angle, then classify it as obtuse, acute, or right. Pause the video, try it on your own, and then we'll do it together. Number 6, angle CGE. Angle CGE, there's my vertex right there. Ray GC is actually on the line. 0 is the outside number, so I'm going to use the outside numbers when I find where ray GE is. It's between 50 and 60, right at 55 degrees. So the measure of angle CGE is 55 degrees. It's less than 90 degrees, which makes it an acute angle. Let's move on to the next angle. So I encourage you to pause the video, find the angle measure, classify it, and then we'll do it together. Angle DGE. Angle DGE is this angle right here. Ray GD lies on that bottom line on 0 degrees, which is the inside number. So I'm going to use my inside numbers. Ray GE is between 125 and 130. It's at 125 degrees. That's greater than 90, which makes it an obtuse angle. Let's move on to number 8. I'm going to use a different color here. Number 8 says angle EGF. EGF. Well, each of those rays, ray GE and ray GF, neither of those rays lie on that bottom line. So what we're going to do is ray GE, I'm going to use the outside numbers for both of these rays. Ray GE lies between 50 and 60, right at 55 degrees. Now, because I use the outside numbers for that ray, I need to use the outside numbers for ray GF. Right there, the outside number would be about 102 degrees. So what I'm going to do here is the absolute value of the difference. 102 minus 55. 102 minus 55 is 47. The absolute value of 47 is 47 degrees. That's less than 90, which makes it an acute angle. Let's move on to the problem-solving portion. Okay, so again, when you're given a bunch of words and kind of a scenario in a problem and you don't have a figure to go off of, draw one. This says Q is in the interior of angle NOP. Find the measure of angle NOQ if the measure of angle QOP is 60 degrees and the measure of angle NOP is 108 degrees. Okay, so Q is in the interior. So what does this look like? Of angle NOP, the measure of angle NOP is 108 degrees. So that maybe looks something like this. And if you draw an image and you draw an angle that's like not obtuse or what angle, it doesn't really matter. Just make sure you put in the numbers or expressions correctly, okay? So this is NOP, and Q is in the interior, so it looks something like this. And the measure, I'm finding the measure of angle NOQ, that's this one, if the measure of angle QOP is 63 degrees. Okay, well, if I use the angle addition postulate, that tells me that the measure of angle QOP plus the measure of angle NOQ is equal to the measure of angle NOP, right? I can add those angles. There's my equation. And now we're just going to substitute what we know. Well, I know, use a different color here, the measure of angle QOP, that's right here, that's 63 degrees. I do not know the measure of angle NOQ. That's actually what I'm asked to find, equals the measure of angle NOP. Well, the entire thing, this entire thing right here is 108 degrees. So that's 108. So now let's solve for the measure of angle NOQ. I'm going to subtract 63 from both sides, and I get the measure of angle NOQ to be 108 minus 63 is 45 degrees. All right, let's move on to the next one. This says ray, and I'll zoom in just a little bit here. Okay, ray BD bisects angle ABC. Okay, well, let's draw that. And I don't know if ABC is acute or anything. I'm just drawing it, right? ABC. And if ray BD bisects it, then I know these two angles are congruent. Okay, awesome. So we've just kind of drawn what we know so far. Now we know the measure of angle ABD to be 3x plus 11. That means this is 3x plus 11. And the measure of angle DBC to be 4x minus 1. This says to find the measure of angle ABC. Well, I can't really do anything until I find the value of x. How would I do that? If these two angles are congruent angles, then their angle measures are equal, which means I can set these expressions equal to each other to find the value of x. I need one equation and one variable to find the value of the variable. So I've set up that equation. Now let's solve for x. I'm going to subtract 4x from both sides, so I get negative x plus 11 equals negative 1. I'm going to subtract 11 from both sides to get negative x equals negative 12. When I divide both sides by negative 1, I get x equals 12. So now I've found the value of the variable. What can I do at this point? Again, I'm looking to find the measure of this entire angle right here. Okay, what can I do? Well, I know that the measure of angle ABD, I know that to be 3x plus 11, and I know the value of x to be 12. So can I substitute 12 in for x? Sure. 3x plus 11 is 3 times 12 plus 11. 3 times 12 is 36. 36 plus 11 is 47. That means the measure of angle ABD is 47 degrees. Okay, so now we know this angle measure is 47 degrees. If that angle measure is 47 degrees, this angle measure is 47 degrees. What can we do now? Well, I can do 47 plus 47, or I can do 2 times 47. So the measure of angle ABC is 2 times 47, which is 94. So the measure of angle ABC is 94 degrees. And that's my answer. Let's move on to the last problem. In mine, which yours is already corrected, but I do need to correct mine, this should be EBF. EBF right here. And yours is correct. So in the figure below, this figure right here, The measure of angle CBF, that's this one right here, is 1/2 x plus 18. The measure of angle EBF is 2x plus 3. That's this angle right here. And the measure of angle DBE, use a different color, is 6x plus 8. It says to find the measure of angle ABD. This is the one I'm looking for. And I used 2 arc marks there to show that it's not congruent to those other angles that have the same arc mark. Okay, so I have an expression, or I have expressions for each of these angles. What do I know? What can I do first? Where can I start? Well, I know I have 2 congruent angles right here, which means I can say that 2x plus 3 equals 1/2 x plus 18. So I can set their expressions equal to each other since their angle measures are equal to each other. Okay, the first thing I need to do is move the x's to one side. So I'm going to subtract 1/2 x from both sides. Okay, how do I do this? 2 over 1 is the same as 4 over 2. 4 over 2 minus 1 over 2 is 3 over 2. Right? So 2 minus 1/2 is 1/2. 1/2 as a fraction is 3 over 2. 3 over 2x plus 3 equals 18. Now I'm going to subtract 3 from both sides. And I get 3 over 2 times x equals 15. How do I undo this fraction right here? I multiply by the reciprocal. That gets rid of that. X equals what I do to one side, I have to do to the other. 15 times 2 is 30, divided by 3 is 10. So I get that x equals 10. All right, let's find some angle measures. I know that the measure of angle CBF right here is 1/2 x plus 18, okay? And the measure of angle EBF is the same angle, right? So let's do this. The measure of angle CBF, the measure of angle CBF is 1/2 x plus 18. I know x to be 10, so that's 1/2 times 10 plus 18. So the measure of angle CBF, 1/2 times 10 is 5. 5 plus 18, what would that be? 23 degrees. So that means this is 23 degrees. That means this is 23 degrees. Why? They're congruent angles. Their angle measures are the same. Let's move on to angle DBE. The measure of angle DBE, that's this one right here, okay? DBE is 6x plus 8. I know x to be 10. That's 6 times 10 plus 8. So the measure of angle DBE is 6 times 10, which is 60, plus 8, which is 68. So this is 68 degrees. And then this right here, we don't know what it is. So let's just call it y for now. So we'll call this angle measure y. Now I know all of these angle measures added together should be 180 degrees because all of those angles added together make a straight angle. So we're going to do 68 degrees plus 23 degrees plus 23 degrees plus y, and we're going to set it equal to 180 degrees. Those angle measures added together equal 114 degrees plus y equals 180. When I subtract 114 from both sides, I get 66 degrees, which means the measure of angle ABD, which is what we were looking for, is 66 degrees, and that's your answer. That concludes today's notes over naming and classifying angles.